Alright, hi guys. So today you guys are gonna still go over Learning Target 6.1. That's really what you guys have been on this whole time. But it is, I can simplify involving powers. And specifically today you guys are gonna go over, scientific notation. Okay. So scientific notation is used to write really big numbers in a simplified form or really small numbers in a simplified form. And how we do this is using multiples of 10. So we have c times 10 to some power. And our number c, it has to be greater than or equal to the number 1, but it has to be less than 10. So we're putting a boundary on it. So it could be something like 6.8, but it couldn't be 13. It has to be something in between 1 and 10. So the reason that we use scientific notation and why it works is our number system consists of multiples of 10. So when you guys were in elementary school, you guys talked about like that's the tens and that's the hundreds spot. And then if we go backwards, that's the tenths and the hundredths with the th on the end. So what mathematicians or scientists, I'm not really sure who made it up, but what they did is they simplified to be able to write numbers times 10 to the whatever power, and it just makes it simpler to write. So, for example, if we had something like 0.1, that is the same thing in scientific notation as 1 times 10 to the negative 1 power. And to you guys just learned about with negative exponents, we move it to the bottom to become positive, right? Well, it's related to this. So if we had 1 over 10 to the 1, this is the same thing. All three of these give you the same number, and that's 0.1. If you were to simplify either of these, it's going to give you that. So, sorry. So scientific notation. So some examples. And by the way, Chris, feel free to pause at any time. So, example A. Let's write in scientific notation. Okay. So, part A on this, let's do 34,000. So, this number, technically, has the decimal point after the zero of the last zero. Oops, there we go. Oh, why does it want to do that? So, we have our decimal point there. So, we need to move it to get a number between 1 and 10. So, if I move it in between the 3 and 4 here, oh man, that's going to give me 3.4. So I know I'm going to have 3.4 times 10 to the something. So to find out how many 10 spots we moved, we're going to just go from one decimal point to the other. So we're going to go over 1, 2, 3, 4 spots. And because 34,000 is a big number, right? The power needs to be positive because it's like, from what you guys learned, that it stays on the top. The positive power is on top of the fraction. So it's 3.4 times 10 to the 4th power. So let's do another one. So part B. Let's do a small number this time. So if we have 0.00032, so we have our decimal point, and we need to move it in between the 3 and the 2 to get a number between 1 and 10. And we move it 1, 2, 3, 4 spots. But because we moved it in the other direction, I have 3.2 times 10 to the negative 4th power. Okay, so let's do just one more just to make sure. Let's do 6, 4, 7, 8, 0, 1, 5, 0.68. So I did a big one. And you guys are like, don't do that. Okay. So we got this long fangled number, and we're going to move the decimal point over between the 6 and the 4 in order to get a number between 1 and 10. So I have to figure out how many spots did I move it over. So I move it over 1, 2, 3, 4, 5, 6 spots. So what happens is I have 6.47 times 10 to the 6, because I moved it to the left. It was a big number, so it has a positive exponent. And I could have rounded this actually. I probably should have done, sorry, now that you've written down, you're mad at me. I really should have done it to the 8 right there. It's a nice place to round it. It really doesn't matter how many spots after that decimal point you go, but you don't want to go too many because the point of scientific notation is to write it smaller. So I would say, I don't know, you should probably ask Rebecca, but from what I know, a couple of points afterward is okay. So there are 6.478 times 10 to the 6th power. So we've gone from scientific notation, from standard notation. By the way, these are standard notation. And these are scientific. So we've gone one direction, and now we're going to go the other way, going from scientific to standard. Alright, so let's do that. So, example B, we're going to write in standard notation. Okay, so let's write 2.6 times, ooh, that's a horrible, times 10 to the 3rd power. So how I like to do it is I write my 2.6 down, and then think about what direction am I going to move my decimal point. Well, it's a positive power, this 3 there. So what I need to do is I need to make it a bigger number. So that means my decimal point is going to move to the right 3 spots. So I start at my decimal point and I go 1, 2, 3, and I fill in my spots there with zeros, and that's the number in standard notation. So let's do another one. So let's do 5.86 times 10 to the negative 4th power. So I write my 5.86 down. And it's to negative power this time, so I need to move it to the left because my number needs to get smaller. So I move it 1, 2, 3, 4, and I fill in my zeros, and voila, 0.000568 is the number in standard form. Alright, so that's just the basics on standard notation. I'm really hoping that you guys are remembering this from the past. So, because we're going to move on and we're going to go to using what you guys have learned about multiplying with powers to do some problems. So that's what's next here. So, example C is we're going to multiply 2.6 times 10 to the 7th power. Sorry, that's a 7. That didn't look right. Times 6.3 times 10 to the 4th power. Okay, so step 1 is you guys are going to do 2.6 times 6.3. So you're taking the two front numbers, you're multiplying the two decimal numbers together. And when you do that, you're going to get 16.38. Okay, so step 2. And actually, I guess let's clarify just to write the notes here. So you multiply the decimals. Okay. So then what you do, step 2, is you're going to add the exponents. And the reason we're adding them is, as you guys learned, when you're multiplying two things together and they have powers, you add the exponents. So we're going to add 7 and 4, and that gives you 11. So if we were to write this in scientific notation, we would have, or at least start right in scientific notation, you've got 16.38 times 10 to the 11th. But if you guys pause for a sec and look at this, what you should notice is the 16.38, that's breaking the rules. It's larger than 10, and we can't do that. So it's technically not in standard notation right now. So what we have to do in step 4 is you've got to move your decimal point over, and we need to move it over one spot. So we need to make it 1.638 times 10, but because we move that decimal point, that affects the power in my scientific notation. And just like when we went from standard notation to scientific, when you move a decimal point to the left, it increases the power of the exponent because you're moving it to the greater side, I guess is what I should say. So it makes it to the 12th. So you're adding that extra, once you move it to the decimal point to the left, it changes your power to be 1 greater. So if you had to move it twice, you'd add 2, okay? So let's do another one that is where we don't have to write out like all the steps in detail. So actually, we'll just call this example C, but part B. So we're still doing the same thing, but the second part of it. Okay. So if we have 4.4 times 10 to the 6th power, and we're going to multiply it by 3. Well, that's not a 3. Okay, 3.9 times 10 to the 4th. So we multiply 4.4 times 3.9, and I get 17.16. Then you're going to add the powers, so 6 plus 4 is 10. So for right now, we've got 17.16 times 10 to the 10th. And I know I'm going fast, so I'm actually going to pause myself to let you guys write that down. Alright, if you guys need more time, just pause the video. So 17.16 is breaking the rules right now, so we need to change it. So I'm moving it 1 to the left, so 1.716 times 10, and that increases our power, so it's to the 11th. And I want to state that you may not always have to do that step. It may be a number between 1 and 10, and then you get to leave it alone. You're done. That last step is not necessary. It's only when you have a number that is greater than 10 that you have to do that. That you have to move the decimal point to the left and add it to the exponent, okay? Alright, one last example, and then I swear you guys are done. So, now you get the fun of division. So, example D. Alright, so what we're going to do is we are going to divide 1.23 times 10 to the 11th. Oh, that's a funky looking 11. 11, close. Okay, divided by 2.4 times 10 to the 4th power. Okay. So, similar to multiplying, you're going to, in step 1, you're going to divide the decimal numbers. So we're going to do 1.23 divided by 2.4. And when we do that, we're going to get 0.5125. step 2. So when you're dividing, what do you guys do with the powers? You subtract them, right? I'm hoping you guys said subtract when I paused there. Okay. I know, this is weird. So we're going to subtract the powers. So you're going to do 11 minus 4. And that gives me 7. Okay, so step 3. If we were to write this out, right now, how we have it is 0.5125 times 10 to the 7th. And you guys should notice right now, it's breaking the rules. So, we need to change it. And the reason, that it's breaking the rules is because 0.5 is less than 1. It's not allowed. So, we need to move the decimal point this time to the right to be 5.125. And we moved it to the right this time. So we made the number technically bigger. But that makes the exponent smaller. So because we moved it to the right one, it turns into 10 to the 6th power. Because just like when we write a number from standard notation to scientific notation, when you're going from a small number and you're changing it to a big number, it's going to basically subtract a 10 spot, so it's going to lessen the exponent. Alright, so really quick, just one, not showing all my work, so 5.76 times 10 to the 9th, okay, divided by 3.2 times 10 to the 3rd. Okay, so I'm going to get 5.76 divided by 3.2 gives me 1.8. And 9 minus 3 gives me 6. And so we need to check, does 1.8 break the rules? No, it doesn't. It's greater than 1, less than 10. So voila, that is my answer. Okay, but if it hadn't been, so said it had been like 18 point something, then you'd have to move the decimal to the left, and then you would subtract an exponent. Oh, sorry, I got myself mixed up. If it was like 0.18 and you had to move it, then it's going to subtract 1 from the exponent. Alright, I'm just going to be quiet now. So, yeah, that's it. Have fun. Bye.